Alright, so when we had epsilon equal to 3, the solution to this inequality was the interval 1 to 5. In other words, x between, as long as x is running around between 1 and 5, this inequality is satisfied. So what's this mean now in terms of the delta? Because remember what this inequality is saying. Let's go to the real number line. Let's put 2 there. And let's do a little bit of intermediate algebra. If we're saying the absolute value of x minus 2 is less than delta, we're saying that minus delta is less than x minus 2 is less than delta, or 2 minus delta is less than x is less than 2 plus delta. So if I add 2 across that inequality, that's what I get. So what I'm doing is I'm setting up a symmetric interval around x equals 2. So I can go up to delta here, and I can go back delta to here. This part, remember, means we don't care what's actually happening at 2 itself. So we're going to ignore what's actually happening at 2. And we're trying to set up a symmetric interval around 2 where everything behaves as it should. So here's my solution set. My solution set is x between 1 and 5. If x is between 1 and 5, this inequality is exactly what it needs to be. So let's put that on the number line. We'll put 2 in there where it needs to be. And so this is the solution to this inequality. Okay, so what's my delta? Well, look, how far away from 2 can I get on this side? Well, 1 unit. How far can I get over here? That's 4 units. I need to have a symmetric interval around 2 that is inside the solution set. So what I'm going to do is just go 1 unit then either side. That would get me on the interval 1 to 3. So that means my delta then is 1. Okay, part C asks us to interpret part B graphically. So what I've done is I've graphed y equals f of x squared minus 6x plus 7. Hopefully you remember from college algebra that that's supposed to be a parabola opening upwards with a vertex at 3, negative 2. I've used a computer to graph it for us, so we have a more accurate graph to play around with. The limit we were concerned about is the limit as x went to 2 of f of x, and we claimed that was negative 1. So we're going to be looking near x equals 2, so there's 2 on the x-axis there. And as x gets close to 2, the f of x values indeed look as if they're getting close to negative 1. So this is our L. Our L, our target limit, is negative 1. So what's the epsilon then? We were given the epsilon is 3. So the idea was we wanted the y values on the parabola to be within 3 units of negative 1. So I march up the y-axis here. 3 units is going to get me to 2. So my L plus epsilon, the upper bound, is this dashed line L equals 2. Or excuse me, y equals 2. What's the lowest I can get? Well, L minus epsilon, I'd be counting down 3 units, down to negative 4. So L minus epsilon is negative 4. So I don't want the parabola to ever be lower than this dashed line, which it never will. So really the issue becomes making sure the parabola is below this dashed line. So if I look at where this dashed line meets the parabola, and I trace down, well, guess what? 1 and 5. Does that sound familiar? When we solve the inequality, the absolute value of f of x minus L less than epsilon, we got an answer of x is between 1 and 5. And sure enough, for any x values between 1 and 5, the parabola is between these two dashed lines. What we had to do for our delta is we had to look at a symmetric interval around x equals 2. The furthest I could go to the left was 1 unit. That means the furthest I can go to the right to make a symmetric interval is also 1 unit. And so this was our choice of delta. And sure enough, if you pick any number delta between 1 and 3, the parabola is between these two dashed lines. You can also see from the picture pretty clearly that delta equals 1 is the biggest delta I could pick. If I said pick delta equals a half and only let myself roam a half a unit away from 2, then the parabola is still within these dotted lines. And in general, that's what's going to happen, folks. Whatever delta you come up with is always going to, is usually the biggest delta. Any smaller delta you pick will also do the job. So that'll do it then for number 1.